Hi everyone, it's Miss B, and in today's video we're looking at the Unit 6, Lesson 5 Cumulative Practice Problems for Illustrative Math Geometry. So we're going to start with this here. We're talking more about circles and perfect squares and things like that. So there's a lot of factoring involved, so that's what our first equation here is. We want to match each quadratic expression with an equivalent expression in factored form. So the first one here, A, x squared plus 6x, is actually the one that really stands out because it's only two terms. And in this case, we have a greatest common factor because both of them have an x. So what happens is we can divide x out from both, and we end up with x times x plus 6. So this one will match up with number 5 down here. So let's match that up with number 5. All right, there we go. Now we have a couple more. So you'll notice all of these end up with 6 adding up in the middle, positive 6, but we have different numbers on the outside. So we want things that multiply to give us these different values. So they should all add up to 6, but they're going to multiply to give us different numbers. So we want pieces that multiply together to give us 5 on the next piece. And those are all going to be determined by the numbers in the right-hand position of each of our factors. So multiplying together to make 5 is going to be 5 and 1. Now, technically, with this first question, you could consider that to be, going back to a question we've already done, but you can consider this to be plus 0, and you can think about what makes 0 when we multiply it together. Well, 0 times any number gives you 0, so 0 and 6 would give you that same combination. So that's, I guess, just another little way to use the adding up trick with the last two numbers, or the two numbers on the right-hand position in each of our factors. So moving on to number C, letter C, number C, I don't know, option C. X squared plus 6x minus 7. We want two things that multiply together to give us 7. And that negative 7 specifically is going to be positive 7 and negative 1. So 7 and 1 would multiply to give us 7. They're going to add up to give us a positive 6 since the plus 7 is bigger. For number 8, this one is going to be, out of our two options left, we have 4 and 2. Oh, I meant to do that one in blue. 4 and 2, because 4 times 2 makes 8, and 4 plus 2 gives us 6. And that means our last one here, 9, should be 3 and 3, and those do multiply out correctly. So if we were to write the letters off to the side here, or the numbers to go with the letters, either way, I'll write both, I guess. This one was C, B, D, E, and A. And if you match them up on the left, the letters with the corresponding numbers, this would have been 5 and 2 and 1 and 3 and 4. So either way you want to match those, give you 3 options. You can check out the numbers with the letters with the numbers, or the lines in the middle. Okay, so on to question 2. We have an equation of a circle with x squared minus 8x plus 16 plus y squared plus 10y plus 25 equals 81. We want to answer some questions down here about it. What is the radius of the circle and what is the center of the circle? So we are going to show all of our work. So I am going to make sure that I'm writing everything down here. And we're going to do that by kind of separating these into pieces that we can factor. And so this lesson kind of goes into a bunch of things about perfect square trinomials. And you can see we actually have 2 perfect square trinomials here. And the nice thing is that 81 over on the side here, that's going to be our r squared. So this part here, we can factor into x and a number squared. The y portion is going to be y and a number squared. And then it's all going to be equal to square root of 81 is 9, so like 9 squared. And then we have to make sure we're adding these together in the middle with a plus. So how do we go about figuring out what these numbers are? Well, we're going to look at the square root of the last number, and then we're going to look at the middle number's sign. So I'm going to write over on the side what I'm looking at. Square root of, we'll call it the quote-unquote last number, because it's not technically the last one when we look at the x portion here. And then we want the sign, we'll say the plus or minus sign of middle number. So what we're going to do for each of these is we're going to square root that 16. So we're looking at, for the red stuff, we're looking at square root of 16, and then we're looking at negative 8x. Square root of 16 is 4, and then the sign here is a negative. So we should have minus 4. And then if we do the same thing for the y portion, we're looking at square root of 25, and we're looking at plus 10y. So this is going to be 5 and then positive. So this should be plus 5. And that's how I would narrow down each of those things. So I know I'm not showing all the factoring pieces, but I'm trying to show all of my rationale here. So what is the radius of the circle? Well, that's going to be, and then that's going to be our 81 over there, which makes square root is 9. So the radius here is 9. And then our center is going to be, just highlight the center of the circle. That's going to be coming from the negative 4 and the positive 5, but we're switching those signs. So this is going to be positive 4 and negative 5, because remember we have x minus h squared. I'll write this in black actually, because I have that as blue for the y value. So we have x minus h squared plus y minus k squared equals r squared. And then the center, that is h comma k. So effectively, we're changing the signs of what we see here to reflect a minus h would give us a positive. So that's why the minus 4 gives us positive 4. And likewise, minus k for the plus 5, this is like minus negative 5. So it gives us a negative 5. So that is the answer to that question there for number 2. And like I said, even though I didn't show a ton of work, I'm showing my rationale for each of them for the x portion and the y portion and how I'm getting those numbers. Okay, for number 3, this says to write 3 perfect square trinomials and then rewrite them as squared binomials. So you can't just start with the squared binomials and then turn them into trinomials. We're going to do this the proper way. We're going to start with, I know I should always have x squared. And I can start with a number that I want to square. So in this case, let's use 7. So I would then say my last number is going to be 7 squared, which is 49. And then my middle number is going to be whatever number I have here multiplied with, this will be 1 squared, and this is like 7 squared. I'm going to multiply that 1 and the 7 together, just make 7, and then double it. So this should be 1 times 7 times 2, which is 14. But now I get to make that choice, well, 14x, sorry, this is always times your variable. Now I get to make the choice, do I want this to be positive or negative 7? Because no matter what, this will always be a positive number. So I can say I want negative 7 squared, And then this -7 would make -14. So what I've created is x minus 7 squared. So I'm going to write over to the side our basic form of this. If we have ax plus b and we square it, it gives us a squared x squared plus 2ab plus b squared. And that's the pattern I'm going to follow. So I don't actually need the one out front here, so I'm going to get rid of that. And so this is one of them. I'm going to do another one in red. So let's use something more complicated. I'm going to use a 2x squared, and I'm going to use let's square. What's a perfect square? 36 is a perfect square. So I'm looking at the square root of 36, which is 6. Oh, and you know what? 2 is not a perfect square. What am I doing? Let's use 4. That's what I was thinking. So now I'm going to do 2 times 6 times 2. So 6 times 2 is going to give me 18, times 2 again is going to give me 36. So I'm going to have 36x in the middle here. And let's make this one positive. So what this factors out to be, I wanted my first term to be 2x, and then my last term here is 6. Oh, I multiplied by 6 again. It's not 36. See, I'm making mistakes here. If I have 2 times a times b, my numbers here are a is 2 and b is 6. 6 times 2 is 12, times 2 is 24. Look at me messing up. There we go. So this would be a second one. Okay, let's try something less complicated so I don't have as much to store in my brain. We'll just do a basic x squared. And instead of doing a negative like I chose to do on the top one, we'll just do a positive one down here. Let's use a bigger square number. I'm going to use 196. So x squared plus 196. Now that square root is 14, and 14 times 2 is going to be 28x. This is going to be x plus 14 squared. And I forgot to put the squared on here, probably because I was so distracted by making that mistake. So there we go. I have 3 perfect square trinomials written as squared binomials. So that's going to bring us to the back. All right, I'm sorry if the cut between these portions of my video is a little weird. I made a big mistake on this question 4, and I just did it really confidently and then didn't realize it until the complete end of the question. It says write an equation of the circle that has a diameter with endpoints 12, 3 and -18, 3. In my brain, I used this as the radius, and so I ended up with a circle that was twice as big as it really needed to be. So we're going to do this the right way this time. I'm going to start by finding the center. So finding the center is actually fairly straightforward as long as you kind of understand what you're doing here. So I'm going to try to remember to include this on my notes for my class today, but the center we can really do is the average. So I'm just going to put AVG of, it's going to be the average of the coordinate values. So I'm going to just say coord values. So this is really also what we would call maybe the midpoint formula if you have two things on a coordinate plane. We would do an x value plus an x value and divide that by 2 and use that in our coordinate pair as the x value. And the same thing with the y values, y plus y, and divide that by 2. So this is what I'm going to do right here. So x values and y values, I always get a little mixed up with them. I'm going to highlight them some different colors for myself. X values are going to be this pink color, and I'm going to use green for my y values. It just helps me see the difference. So when I'm adding the x values, I'm going to make sure I do both of those pink ones. So this is going to be 12 plus a negative 18, and we're going to divide that by 2. And for the y values, it's going to be 3 plus 3 divided by 2. Now, when we say average, that's really the mean. It just means that we add them up and divide by how many there are, and in this case, there's 2. So 12 plus 18 gives me negative 6. When I divide that by 2, we get negative 3. And 3 plus 3 is 6, and when we divide that by 2, we get 3, because both of those numbers were the same. So this is my center, is 3, 3. Now, we need to find the radius. We can actually do this by plugging in some numbers. So remember, we have x minus h squared plus y minus k squared, and that's equal to the radius squared. So as long as I have enough numbers to plug in here, I can solve for the radius. And so I'm going to use, here is my h comma k. That's my negative 3 comma 3. I'm going to plug those numbers in for h and k, and then I can plug any of my other numbers in from either of my 2 points as x and y values. And then that'll just leave me with r in order to solve. So let's do that part here. So we're going to work to find the radius on this part. And then I might have to write my answer a little bit like up above it or something. But I'm going to use that formula. So we're going to plug in, I'm going to use this one here, the 12 and 3. So 12 is going to be my x, and that's going to be minus negative 3 squared. And then I'm going to use k is going to be the positive 3, and y value here is actually 3. So we're going to have 3 minus 3, because y minus k, and we're going to square it, and that's equal to the radius squared. What I did wrong the first time was I just used these 2 points instead of using the center in one of those points. And that gave me something that was twice as big. But we still use it the same way. So 12 minus negative 3, that's really 12 plus 3. So that's 15 squared. And then 3 minus 3 is 0 squared. So I really have 15 squared equals r squared. And what we can do is we don't need to like multiply it out and everything. We can square root both sides just right here, because a square root, oops, doesn't erase. I'm not trying to erase there. It just cancels out with the squared portion. And it is a balanced operation. We're allowed to do that to both sides. So we're just going to have that the radius is 15. And on the last one, I got 30, and I was like, well, that's a really large equation there. Yeah, you think, Miss B, when you use the diameter as the radius endpoints, that's what happens. So I'm going to try to write this in the middle here as my answer, and then I'll put a box around it so it's less complicated. That means I'm going to have x plus 3 squared plus y minus 3 squared, and I'm going to have it equal to 15 squared. I like to write the radius as a number squared because then it's easier for me to just read it from the question. And then let's try to move this so I am not, there we go, overlapping on top of that 15 with my box. So that's my final answer there. X plus 3 and y minus 3, each of those are squared, added together equal to 15 squared. Okay, let's move on to question 5. We're going to graph this circle and then do some other stuff first. So let's find our center. I'm going to identify what's h, what's k, and what is r. So h comma k is going to be 2 comma 1, and then r, because this is r squared, my radius is going to be 5. So I know that I tend to write it as 5 squared, but you have to double check. We have to use the square root of this to get this number. So graphing that circle 2 comma 1, that's going to put my center right here. And then if my radius is 5, that's going to be kind of big. It's going to go a little bit off to the side. But I can go 1, 2, 3, 4, 5 down, and that one lands, and 1, 2, 3, 4, 5 to the left, and that one lands. But it's going to go one space up off the top, and it would go maybe like 2 spaces off the side here. I'm just going to put it at the very edge of my paper. It's going to be hard to see. So I'm going to do my best to connect all of these points in something semi-circular. Good enough. Thank you, iPad Magic, for drawing that in for me. Now, after we've graphed it, we're going to try to determine if each point is on the circle, and if not, whether it's inside or outside of the circle. So if it's inside the circle, that means that the value is going to add up to be less than 25 in this case, because that's our r squared. And outside of the circle would mean that the value is going to be greater than 25. Now, if it's on the circle means it is just going to be straight up equal to 25. So those are our 3 options. On the circle is going to be equal to. Inside means that that radius is less. So it's less than 25. So let's plug each of these in. And we're just going to evaluate each of these points. So we are just going to do the left-hand side of this, really. So we're going to do 4, yeah, 4 minus 2 squared, and we're going to add that with 0 is the y value here, minus 1 squared. And we're just going to actually evaluate what this is. So 4 minus 2, that's 2. 0 minus 1 is negative 1. 2 squared is going to be 4, and 1 squared is 1. And that is going to be 5, which is less than 25. So I'm going to say that this one is inside. I'll change my colors up just so that my work isn't running into itself here. Now I'm plugging these values in for x and for y in the equation. I'm leaving the h and the k values that they gave me in the equation of negative minus 2 and the minus 1. I'm leaving those. So I'm going to now have negative 3 minus 2 squared. I'm going to add that with 3 minus 1 squared. So this makes negative 5, and this makes negative 2. 5 squared is 25, and 2 squared is 4. That makes 29, and since that's greater than 25, this one is going to be outside. So I'll write that in black. Outside. And then the last one, I'll just do this one in blue. We're going to have negative 2 minus 2 squared plus negative 2 minus 1 squared. This is going to give me negative 4. I'm going to square that. And then negative 3. So negative 4 squared is positive 16. And negative 3 squared is positive 9. That's equal to 25. So this is going to be on circle. It looks like a D just because I'm writing it a little close together. On circle. It's a CE, not a D. So there we go. We have those 3 pieces, outside, inside, and I know my colors didn't line up with the way I labeled in the top equation, but you guys can manage. So how can you use distance calculations to decide if a point is inside or outside a circle? We actually just kind of talked about that. So we want to know, so less than radius from the center is inside. We're going to say more than radius from center is outside and equal to radius from center is on the circle. I guess I kind of answered that question before I did part B, huh? And so last one here is a triangle transformation. So the triangle whose vertices are 2, 5, 3, 1, and 4, 2 is transformed by this rule. So we have x, y transforms to x minus 2, y plus 4. We want to know, is it similar or congruent to the original figure? Well, if I am just subtracting and adding numbers, this is a translation because I'm just moving those points. And so it is going to be A, which is congruent because it is a rigid motion. Now, they didn't ask me to put a reason, but I'm going to give you a reason there. And that's it for assignment 6-5. So that's the Unit 6, Lesson 5, Cumulative Practice Problems for Illustrative Math Geometry.